Hello and welcome back, students. We're working today on a couple of new rules for doing derivatives. And these rules are going to be used whenever you have a product or multiplication of functions that you cannot simplify in any other way. And likewise, a quotient of two functions that can't be simplified and you just cannot get rid of that quotient. So I've written out the product rule for you. So when you are doing the derivative with respect to x of f of x times g of x, so in other words, two functions times each other, then your derivative is f of x times g prime of x plus g of x times f prime of x. And you can memorize it like that, but I actually have a little saying that might help you. So you may want to write this down. I would call your f of x function first and your g of x function second. So let me see if I can get those on here. So first, having trouble getting it to write that ST. And second. And then your derivative would go like this. So it's first d second plus second d first. And that d stands for derivative. So if you consider your first function times your second function, again, it's first d second, so derivative of the second function, plus second, and then d first, the derivative of the first function. So one way or the other, you're going to need to know and be able to apply the product rule, and we'll have several examples of doing that today. And then I also have for you the quotient rule, and it has a saying as well. So I'll state the quotient rule for you. The derivative with respect to x of f of x over g of x is g of x times f prime of x minus f of x times g prime of x over g of x squared. Now this one's maybe a little more catchy in terms of the saying. I'm going to label the first ones as hi and ho. And so it goes like this: ho d hi minus hi d ho over ho ho. And maybe that'll help you remember the quotient rule. So ho d hi minus hi d ho over ho ho. And there are various other sayings for that, but that is one that I've heard most often. So ho d hi minus hi d ho over ho ho. And then you also have your derivatives of the remaining trig functions. And I'll go ahead and do those for you. I'll have to clear the ink off this screen to scroll up. So going on to derivatives of your trig functions, the derivative with respect to x of the tangent of x is secant squared of x. And you might just realize that that means the same thing as the secant of x squared. So those two notations mean the same thing. The derivative of secant of x is secant of x times tangent of x. So often I'll say it as secant tangent, just as an abbreviation, secant of x times tangent of x. Remember, I told you the derivatives of all the co's are negative. So the derivative of cotangent of x is negative cosecant squared of x. Negative cosecant squared of x. And like the other one, that's the same as negative, and then putting it in parentheses, cosecant of x squared. And I'm sorry, my pen is not writing very well. And then the last one, the derivative of cosecant, it's another cos, so it's negative, is negative cosecant of x times cotangent of x. So you've got those four rules, and if you'll notice, the tangent and the cotangent are very similar to each other, and the secant and the cosecant are very similar to each other. So if you can memorize particularly these two, then just think about the other two being cos. They have to be negative, and they are very similar in their derivatives. So those are your remaining four trig rules. All of these rules you're going to need to have memorized. Hopefully you will use them enough that you will know them. So the rest of this video is going to be working on doing derivatives using all of these rules. And so I'm going to go ahead and scroll down, clearing this ink, and going on to our first example. So this first one says to find the derivative, your f of x is x minus 1 times x to the second minus 2. Now this is actually one that we could get rid of the product. So we could go ahead and do a rewrite on this. We could multiply out x minus 1 times x squared minus 2 and have a polynomial to work on. But I think that this is an easy one to show you the product rule. So I'm going to go ahead and do the product rule with it. So the x minus 1 would be first, and the x squared minus 2 would be second as you do the product rule. So f prime of x would equal first, which is x minus 1, times the derivative of the second. Well, the derivative of x squared minus 2 is 2x. And then the derivative of the negative 2 is just 0, so just 2x there. Then you have a plus sign, and then we do the second, which is x squared minus 2, times the derivative of the first. Well, the derivative of x minus 1 is 1. And then the rest of your work on this would be just to simplify this. So, for example, you could distribute 2x to the x minus 1. That would give you 2x to the second minus 2x. And then likewise, you could take 1 times x squared minus 2. And then combining your like terms, your f prime of x would be 3x to the second minus 2x minus 2. And there is your first example. Once again, you could have multiplied this out to a polynomial and then work the derivative with the power rule, but this one was a good illustration of the product rule. So if you'll go on and turn your papers over, we will continue with your second example, which is a product that we cannot remove. So you have f of theta. Don't let the theta be something that's intimidating. That's just like saying f of x. Even if I were to distribute cosine of theta, I would have a term that says theta cosine theta. And that's a product. So I cannot get rid of this product by simply multiplying things out. So I must do the product rule. And I'm going to go ahead and leave it in this form and do the rule. So theta plus 1 is first. Cosine theta is second. And so f prime of theta would be first, so theta plus 1, times the derivative of the second. Well, the derivative of cosine is negative sine of theta. And then we have plus, and then we'll do second. Second is cosine of theta times the derivative of the first. Now, the derivative of theta plus 1, theta is just like an x. The derivative of just a variable is 1. And so the derivative of theta plus 1 is just 1. And you really don't have a lot of simplifying to do, just a little bit. We can distribute the negative sine of theta. So that would be negative theta times the sine of theta, and then negative sine of theta times 1. And then we can take 1 times the cosine of theta and just have cosine of theta. And that actually is as simplified as we can go on this one. So there is your product rule for a trig function, but something that you just cannot get rid of, the multiplication. So you have to keep it. Okay, I'm going to move on to your third one. And for this one, I'm going to illustrate the quotient rule. Now, you could rewrite this one so that you don't have a quotient. So I could have already assigned this one to you. You could, and I do want to at least show you what I'm talking about there, but I'm not going to do it this way. So I could have rewritten it so that, actually, I'm going to do one rewrite that I will keep. I had x plus 1 over, and then the square root of x is x to the 1/2 power. I could have kept going, or I could keep going with my rewrite, and I could put x over x to the 1/2, and then plus 1 over x to the 1/2. And I could keep going on that until I had separate terms that would allow me to do the power rule. But to illustrate the quotient rule, I'm going to use the version that we have right here. So a good rewrite, this right here is a rewrite, would be to get the square root to a fraction exponent. Now, once you have that rewrite, then your derivative, f prime of x. Now, this is a quotient, so we're going to do the quotient rule. So this is high, and this is ho. And so we're going to do ho d high. So x to the 1/2 times the derivative of the top, when the derivative of x plus 1 is 1, minus high d ho. So the top, which is x plus 1, and the derivative of x to the 1/2 would be 1/2 times x to the negative 1/2, because we'd have to subtract 1 from our exponent. And then all of this is over ho-ho, which would be x to the 1/2 squared. And then we need to simplify. So now you're going to need some space to do your simplifying. So you may want to start to write a little bit smaller because we're going to do quite a bit of simplifying on this. So f prime of x, would be equal to, all right, I'm going to take x to the 1/2 times 1. And then I'm going to distribute the 1/2 x to the negative 1/2. So when I do that, I'm also going to be distributing the negative sign along with it. So I'll have negative 1/2 x. Now, when I take these two terms times each other, I have to add the exponents. So I have an exponent of 1 that I'm adding to negative 1/2. That's going to give me an exponent of positive 1/2. And then I'm going to be taking 1/2 x to the negative 1/2 times 1. I'm also distributing this minus sign while I'm at it. So that's going to be minus 1/2 x to the negative 1/2 power. And then all of this is over our denominator, x to the 1/2 squared. You multiply the exponents, 1/2 times 2 is x to the first. So now we're looking at like terms that we can combine. So f prime of x is going to equal, and I have two terms that have a 1/2 exponent right here. So I add the coefficients. I have 1 x to the 1/2 minus 1/2 x to the 1/2. So that is going to simplify to 1/2 x to the 1/2 power minus 1/2 x to the negative 1/2 power. And then all of this is over x. So we are going to make the rule that we do not want to leave these fractions within fractions. So we don't want to have complex fractions in our final answers. So I'm going to move over in here to continue working. In fact, I'm going to go just a little bit higher here and work over in this area. So f prime of x will equal, now I'm going to be factoring out the greatest common factor. 1/2 is part of that. I'm looking at your numerator. 1/2 is part of the greatest common factor. But I also have x's as a common factor. And so I'm going to take out an x, and I always have to use my lowest exponent. So my lowest exponent out of 1/2 and negative 1/2 is negative 1/2. So I'm going to factor that out. Now, factoring is like dividing. So when I am factoring out 1/2 x to the negative 1/2 down here, and I'm even going to do it in a different color so you can see what I'm doing. I'm going to show you what that's like. So here's my current numerator. This is my current numerator. And I am factoring out, which means I'm dividing. So I'm dividing each one of these terms in my numerator by 1/2 x to the negative 1/2. That's what factoring is. You're dividing out that greatest common factor. And I want you to see what happens. Well, first of all, the 1/2s cancel. Second of all, your x's, when you're dividing, your exponents subtract. So the subtraction is 1/2 minus negative 1/2. Well, 1/2 minus negative 1/2 becomes plus positive, and 1/2 plus 1/2 is 1, and that becomes your exponent. So you have x to the first power for that first term. And then for your second one, factoring out 1/2 x to the negative 1/2, which is like dividing, your 1/2s are gone, and these are exactly alike. So they cancel, and that leaves a 1. So it factors leaving x minus 1 inside your parentheses. And then your denominator still remains as x. So we're almost there. I'm going to erase this work down here. But if you need to go back, you can take a look at it in the video again if need be. Your last step is to get the x to the negative 1/2, move to the bottom. And since this is a multiplication, you can actually rewrite this as the 1 from the 1/2 and the x minus 1 from the parentheses over 2, and then your x to the negative 1/2 could move to the denominator, and that was over x. So that's the same as saying it was times 1 over x. And some of you may not need to put it as times 1 over x. Some of you may see it without taking that extra step. Your final answer is x minus 1 over 2x square root x. I'm not going to ask that you rationalize the denominator. Many times we'll use the derivative in a form like this because we'll work with the numerator doing one thing and with the denominator doing another thing. So this is a good form to leave your derivative in. And I do want us to be able to simplify using this technique of factoring. So this part where I took out the 1/2 x to the negative 1/2, that's a key to being able to do the algebra. So be sure to review that, to ask questions on it. And as you encounter problems with it, if you're not getting it, be sure that you ask for help. So I'm going to go ahead and scroll up for the last two examples, which are not nearly this complicated. Number 3 was a really big one as far as something that you'll have to do to simplify the quotient rule. So I'll clear this. We'll move on up to numbers 4 and 5. So number 4, you have f of t equals the sine of t over t. That is a quotient. You cannot get rid of the quotient, so we'll have to do the quotient rule. We'll call the top high, the bottom ho, and it works like this. F prime of t is equal to ho d high, so t times the derivative of sine of t. The derivative of sine is the cosine of t, minus high d ho. So we have the sine of t times the derivative of t, which is 1, over ho. And that would be t times t, or t squared. Now, fortunately, there is no further simplifying for this. F prime of t, I'm just going to clean it up a little bit. That would be t times the cosine of t minus the sine of t all over t squared. It is tempting to think that you could cancel the t's, but remember that this t on the numerator is connected to the cosine of t. It's not t times the parentheses of cosine t minus sine of t. It's t and then multiplied by just the cosine. And so you cannot cancel that. It is not like what I did in problem number 3. So you may want to look that over again. And then finally, we have number 5, 5x times the cosecant of x. So I think I can fit that on this same screen. This is one where people tend to not recognize that it is a product. But 5x anything that has an x in it multiplied by anything else that has an x in it is a product. So this would require the product rule. Put those parentheses around it to help you. The 5x would be first, and the cosecant of x would be second. So when you do y prime, it is first times the derivative of the second. Well, the derivative of cosecant, now you may have to look at what that was. The derivative of cosecant is negative cosecant of x times cotangent of x. It's one of those new ones. Plus, so here we've done first, d-second. Now we're ready to do second. That would be cosecant of x times the derivative of the first. Derivative of 5x is just 5. And for y prime, I can just multiply that together. I can take 5x times the negative cosecant of x, cotangent of x. I could write that as negative 5x times the cosecant of x times the cotangent of x plus, and then put the 5 in front of the cosecant of x. And sometimes it's nice to factor out the common factor. So I'll tell you an alternative final answer could be to factor out the negative 5 cosecant of x and have in the parentheses x times the cotangent of x minus 1. But those last two lines are equivalent to each other. And sometimes it is nice to have a product, especially if you're trying to solve y prime equals 0. So this is the end of your notes and the end of the video on the product and the quotient rule. These are two rules that you'll use from this point on. So make sure that you get the practice with them and ask questions where you need help, especially with the algebra in simplifying.